Alright guys, today we're looking at just a couple of special cases. When we were dealing with slope-intercept, so far we've always done positive slopes or negative slopes. What we're going to do today is we're going to look at a couple of special cases. If you remember from our story that we wrote about Josephus, the skateboarder, there were 4 different kinds of slope: positive slope, negative slope, zero slope, and undefined slope. So what we're going to do right now is we're going to look at those other 2 types of slope and why is it that they are zero slope or undefined slope. Okay, so here we go. We're going to start with zero slope. So remember, first off, the slope-intercept form of a line is y equals mx plus b, and that when we look at m and b, b represents the y-intercept, and m represents the slope. Okay. Now, as we look at these lines, one of the things that you hopefully will realize from this is that we don't just call them zero slope and undefined slope for no reason. There is actual mathematical reasoning behind why we call these zero slope and undefined slope. So let's start with the zero slope. Remember that when we do this, the first thing we always look for is the y-intercept. Okay? So on this line, we're going to look, and it just happens to be right there, where the y-intercept is positive 8. Okay? So we're going to have y equals something x plus 8. Okay? The next part is the slope, and remember when we do the slope, we're looking for the rise over the run. So that means we have to have 2 points. So we're going to just pick 2 points. We'll use these 2. And we have to figure out the rise over the run. Now when you look at these points, it should be very obvious that there is no rise. The rise is 0. You don't move up and down at all. So our slope is going to be 0 over, and then the run, in this case, is 2. Okay? So we end up with y equals 0 over 2x plus 8. However, if you were to actually divide that, what is 0 divided by 2? If you do that, you're going to end up with y equals 0x plus 8. Okay? Now the next part is hopefully fairly obvious for you as well, but if you multiply something by 0, no matter what it is, 0 times anything is 0, right? So then you have y equals 0 plus 8. And we can add that. 0 plus 8 is y equals 8. Okay? So a couple of things happened here. First off, you should notice that as we looked at the different parts of this, when we calculated out the slope, we got a slope of 0. Okay? Hence the name of a horizontal line of zero slope. That's why that is called a zero slope, because the slope is 0. But what's interesting is when you solve an equation of a line that has 0 slope, it's always written as y equals, and then there's a constant, or a number with no variable. And that's always going to be that way. You'll never see a equation for a 0 slope line written as something like y equals 0x plus 8. It's always going to be just written as y equals 8. So that's what you need to keep in mind. If you ever see something where it's just y equals 8, then that's really just saying it's a horizontal line, okay, meaning a flat line, that crosses the y-axis at 8. Okay? So that's the first special case. Our next special case is the undefined line. Now this one is a little bit trickier to try to figure out, mainly because if you look at it, there is no y-intercept. It goes straight up and down. So the first thing we can look at and write is we can say y equals something x, we don't know what it is, but there's no y-intercept. So we don't have anything to write there. It's completely nothing. We don't even write a 0 because even that would be something. So we have no y-intercept, so we can't write anything there. The next thing we would do is we would look at the slope. And if you look at the slope, again, you're going to have 2 different points. That's a little bit off, but you can get the idea. So there's my 2 points that I'm going to use for my slope for this line. Now this time we do have a rise. I have a rise of 2. So I'm going to have my rise of 2. But this time I don't have a run. There's no sideways movement. It's only vertical movement, which means my run would have to be 0. Now this is where the undefined part of this comes in. What I want you guys to do is I want you to get out a calculator or use your iPod or iPad, iPhone, whatever it is that you're watching these videos on. Whatever you have, get out the calculator app for it, if you will, and put that in. Try dividing and saying 2 divided by 0. If you put 2 divided by 0 in, most calculators will just give you an E or an error message. And the reason is it's impossible to divide by 0. There's no way to do it. If you have 2 candies and you say, I'm going to divide this with 0 people, that's impossible because you have the candy. That's one person already. It doesn't matter that you're trying to share it with nobody. Because you already have it, it's one person. If you say, I have 2 pieces of candy, I'm going to share it with 0 people, it can't be done because somebody is going to have that candy. So dividing by 0 is by itself undefined, and that's why we say that a vertical line has undefined slope. It's because there's no sideways movement. At the 2 over 0, the run is 0, so there's no movement sideways. So it's undefined. There's no slope. Okay? So that's the other special case, and typically when you see things written like this, first off, there's no y-intercept, so we can't have y equal to anything. There's also no slope. The way that these are written, okay, we're just going to cross that out because that's impossible. The way this is written is you're going to write it by looking at the x-intercept. And you're just going to write it as x equals, and wherever that crosses the x-axis, in this case positive 6, it's just x equals 6. Okay? So these are your 2 special case slopes. If you have a perfectly horizontal line, then your answer is going to, your equation will look something like y equals 8. And if you have a perfectly vertical line, your answer should look like x equals 6 in this case. Wherever it crosses, whichever axis it is, that's what you would write. All right? So there you go. Those are your 2 special cases. Hope that helps.